in the given problem, aniline will get converted into benzene diammonium salt as product A on treatment with NaNO2 and HCl. A on treatment with CuCN will get converted into benzene cyanide or benzene nitrile, and benzene nitrile will be the product as B. B on further hydrolysis in presence of water H plus will get converted into benzoic acid. So final product C will be benzoic acid. So in this reaction we can see that the reactant is Na2C2 is getting reacted with CO2. So the first reaction, in the very first reaction, Na2C2 will act as nucleophile and CO2 will act as electrophile. So C2 minus so C2 minus will act as nucleophile and CO2 will act as electrophile. So after nucleophilic addition reaction, further H plus will act as acid, which will neutralize the final product formation on reaction with CO2. So let's see. This is C triple bond C minus minus Na plus and Na plus. This is a nucleophile. This CO2 is electrophile here, and C2 minus is attacking onto the carbon of CO2 as nucleophile, and CO2 is acting as electrophile here. So it is giving an addition reaction. So both sides CO2 will get attached because C2 minus have two active sites as nucleophile, so it will attack from two places. So 2 CO2 will be consumed, 2 equivalent of CO2 will consumed for 1 equivalent of C2 minus. So we can see that this is the product we have got after treatment with H plus, or we can say that acid workup. So on treatment with H plus we are getting COOH, C triple bond C, COOH, and then we are treating with this H2PDBaSO4. So after treatment with H2PDBaSO4, it will give a cis product because of syn addition. So now we have to treat this with dilute alkaline KMnO4. This is also called as Bayer's reagent. So on treatment with Bayer's reagent, there will be formation of vicinal diol and it will be a syn addition. So it will add to the from the same side, hence this is called as syn addition. So there will be formation of meso compound, symmetrical compound. So first option is not correct because that is not symmetrical. Second is correct because that is symmetrical. So that is meso compound. So the final compound will be a meso compound. So Bayer's reagent is acting. Bayer's reagent is adding from the same side. So there will be formation of option 2. In this problem, NH2OH is called as hydroxylamine and it will react with ketone to form oxime. So simply under pH value 4.5 to 5.5, that is under slightly acidic medium, hydroxylamine adds to ketone to form a oxime. In this given reaction we can see that ester is going to react with ethylamine to produce amide. Such kind of reactions is called as substitution reaction, nucleophilic substitution reaction at sp2 hybridized carbon atom. So this is a kind of reaction which will happen through tetrahedral intermediate formation. So in the process of the nucleophilic substitution reaction, there will be formation of tetrahedral intermediate. So let's see how it happens. First of all, PHCH2 C double bond O OPH do have a leaving group OPH. So PHO minus will leave out as a leaving group when nucleophile will attack on to the carbonylic carbon atom. So ethylamine is a nucleophile here. Nitrogen have a lone pair, it will attack on carbonyl carbon atom, and C double bond O pi bond will get open into this situation. So after attacking of the lone pair of nitrogen, the CO bond will get open, then come back, and then PHO minus will leave out, because PHO minus is a good leaving group. So such kind of reactions are called as nucleophilic substitution through tetrahedral intermediate, and this substitution reaction is taking place at sp2 hybridized carbon atom. So final product will be PHCH2CONHC2H5. This is a amide. So finally there will be formation of amide. Hence we can say that this reaction is happening, this nucleophilic substitution reaction is happening through tetrahedral intermediate, and PHO minus is a leaving group here. So PHO minus will leave out as a leaving group, and there will be formation of amide as a final product. So such kind of reactions take place in between the ester and 1 degree amine, or we can say between ester and 2 degree amine. So such reactions may happen in between of ester along with 1 degree amine or 2 degree amine. But it will be difficult to perform the reaction with 3 degree amines because of steric hindrance. So preferably it will happen along with 1 degree amine and 2 degree amine. And here nitrogen is an active site that will attack as a nucleophile because that have a lone pair of electron.